Hey everyone, how's it going? It's Nick here. This is a 3D printed 3D printer. Well, about as 3D printed as you can kind of make it. You know when you first buy a 3D printer and you show it to someone who doesn't know anything about 3D printing, and then they'll always crack a joke that is somewhere along the lines of, well, can you just 3D print your own 3D printers now? There's no need to buy any more. Well, I guess that's what I kind of wanted to go for. And so this is the Ratrig VChonk. I have a bigger Ratrig VCore 3.1, and when they announced this VChonk plan, I thought it was absolutely adorable and I wanted to give it a shot, and I've been needing a second 3D printer anyway, so I thought I would go ahead and try out the build. And so throughout this video you might see some parts that are like printed in yellow, or then some are printed in green. I originally printed this in yellow because I really like black and gold and that's my color scheme, but the yellow wasn't quite as gold as I wanted, and gold ABS is, at least from Hollymaker, was pretty ugly, and so I ended up redoing the whole thing and printing it in green. And so you might see some things interchange throughout the video. So this video pretty much is going to be my build process, putting it together, struggles, why I made the modifications that I did, and then just kind of talk about the build in general. And so just so you have some context, I built the Ratrig 3.1. I bought a kit from them, but this one is kind of one of the first ones that I'm kind of really being much more involved. The other one I just printed what they said to print and put it together. This one I kind of had redesigned every single part of this and kind of customized it to the way that I want, which I really think is the strong suit of this project, because it is a 3D printed 3D printer. You can kind of customize everything and kind of modify a lot of the parts. Really the only like stock parts are like the nuts and the linear rails and the belts and the electronics. And so without further ado, let's start putting this thing together. So to start off, I started with some of the easy pieces, and so a lot of this build is going to be done with ABS because I plan to enclose it and print some higher temperature materials than just PLA. And so here I'm just doing the little skirt pieces, and I've just kind of printed a little bit and then planned a little layer pause so I can kind of get this little multicolor effect here. After that, I kind of went straight for the tough ones, the giant base plate. And so here I'm applying some extra magic glue to kind of really make sure that it sticks down to the bed, because I don't want this 24-hour print to fail. But maybe this part was doomed to fail from the start, because here it is quite a bit into the print, and I think once it started doing a little bit of top surface, it started to warp. It was in its enclosure before, but I took it off to film this part. So here you can see that it's starting to lift the build plate, and it's sticking to the build plate very well, but it's very away from the print bed. And so hopefully I guess I'll use some binder clips to kind of clip that back down, and it will kind of fix that for now. And update, it did not fix it overall. Once it started doing more top surface, that was too much for it to handle. The ABS just warped like crazy. And so the top surface is incredibly rough because it lifted into the nozzle, and with all the nozzle crashing, it looks like I got a layer shift too. So determined to not waste almost a full spool of ABS on this messed up part, while it was still hot, I took it off the build plate and then I clamped it down to my desk, which I know is a nice flat piece of wood, and let it cool down there for a long time. And surprisingly, it worked, because this is now flat, at least as flat as I need it to be. So just a little bit of cleanup and maybe I can still make this work. What I ended up doing is just kind of printing just the top part of this base plate that has all the fixtures and the standoffs and stuff like that, and then kind of lining up all of the holes together, and then just using a bunch of glue and of course tape to kind of hold things in place, and then just kind of gluing down this kind of top layer on here. And you know what, it's the underside, no one's gonna see it, so I guess that works for me. But I did end up changing this later with like a PLA version mod of this bottom plate, that was easier to print, but stick around later for more aftermath edits. Next up, I printed the top gantry. This time I used binder clips from the start, and it seemed to work out a lot better. Here I have the front gantry kind of open because it's super annoying to have to deal with this cross beam when I'm recording things and trying to pull prints off the plate, and so I kind of left it open. And if it doesn't work, we'll see if I have to print another one, but for now, we'll give it a shot. And so after the base plate and the top gantry, none of the parts were really kind of any sort of difficult. And so we're gonna go ahead and start putting things together. And so for this, you might see some footage out of order because I found that there's definitely a best way to do this. And so here I'm starting with the bottom of this printer. It's the heaviest kind of part of all of this, and it's probably, this is a lot easier to do than trying to flip an entire printer on its side. And so pretty simply, the power supply, Raspberry Pi, and the driver board sit pretty well into this thing. I'm using a Big Tree Tech Octopus board instead of the SK Rat because I had a spare Octopus from when I was doing maintenance on my V-Core, and that was just kind of the idea of this whole project. When my V-Core kind of went down for maintenance and I didn't know what was wrong with it, I kind of bought an entire another set of electronics of all the other parts so I can kind of swap them out one by one and troubleshoot. And in the end, it just turned out to be a faulty power plug. But I had all of these spare electronics on hand, and so I decided I just put them to use and make another printer with them. And so here, I'm just kind of mounting everything down, and then I'll get to wiring later, but for now, I'm just going to mount it down while I still have easy access to everything. And so here, I've got the pancake motors and all these parts on here, and I'm just using the M3x8 screws to screw in the driver board, the M2.5s to screw in the Raspberry Pi, M3x20s for the pancake motors, and then I think it's the M4s for the power supply. And I'm just going to keep these all down, and then I'm going to go ahead and attach the skirt. And so for the skirt, not all parts are the same. Two sides are longer than the other, so keep that in mind. Front and the back will be the same length, and the two sides are the same lengths. And so here I'm just using M3x8s to kind of send them to the little corner pieces, and the corner pieces are keyed quite nicely, so you can't really do it upside down. So for me, I'm just making them bite straight into the plastic. If it's a part that kind of doesn't get removed in and out a lot, then usually you can bite into the plastic quite strongly, as long as you don't plan on doing that many times over. Now, if you're following along at home, this is where you could save yourself a lot of time. If I were you and doing this over again, I would attach the Z screws now, right after doing the bottom electronics box and the skirt, instead of doing it at the end like I did. What happened was, when I attached the four legs to this thing, now I have no clearance for my screws to attach the bed to the lead screw or the linear rails. So do it before you attach the legs. After that, add your anti-backlash nuts onto these lead screws, and don't forget to set that anti-backlash set screw. One thing I found is that the build plate is kind of really maxed and really tight, and you can definitely ram the bed into the bottom of these coupling nuts if you go all the way down. So what I'm doing here is sliding the coupling nut almost as low as I can go down onto the Z motor to give as much height for the Z rod as possible. But of course, I don't want that bottom of the nut to be scraping against the motor, so it's got a little bit of space. But yeah, I'm sliding the coupling nut down on the shaft almost as low as it goes. And then of course, you want to make sure that Z-rod doesn't wobble around and stays perfectly centered, sticking out of there, even though it doesn't have much space to grip onto that Z-rod. As for the print bed, I went ahead, I just have a blank magnetic sheet, and I'm going to loosely tape that blank magnetic sheet on top of the aluminum build bed, and then I'm going to mark those holes, and then I'm going to drill holes all the way through, so that way I can kind of run my screws all the way through and not have my screws trapped underneath the magnetic surface. Next, I attach the heater pad, and so I just kind of lined it up with the holes on the plate, and to make sure I put it on the side that didn't have the chamfer for the countersunk screws, and then the wire just kind of sticks out the side. And I just kind of flipped it over, put the screws in through, a little nylon washer and then a little stainless steel spacer. And then for my version, I am biting straight into the plastic here. I think on the normal version they have you screw into some lock nuts, but biting into the plastic's been pretty strong and reliable so far, so save my money on some lock nuts. Now I'm going to stick my magnetic sheet on top, and this is just a magnetic sheet and build plate combo that I bought off of Amazon. I think it was for like a different printer or something like that, but handy to have. Next, I'm going to add my linear rails into here. Of course, again, much easier when you didn't attach the sides and the top yet. And then I'm going to go ahead and put my kind of build platform in the middle of this and then just kind of make a sandwich. I'm going to screw the 3D printed part of the build platform triangle thing to the linear rails. Make sure you properly tension your anti-backlash nuts. And then I'm going to attach the build platform to the anti-backlash nuts. And so this is where I started to go even more far off the beaten path. This time I decided that I wanted 3D printed legs instead of the aluminum profile legs. Not because I think they're stronger, but because that, I don't know, I just wanted a more 3D printed 3D printer. And they're surprisingly rigid. And so these ones that I've designed, they're just going to kind of go underneath here. And to attach them, you're going to use your M12 bolts and just kind of sink them in all the way through from the skirt to the base plate and into the legs. And then these ones, instead of using corner brackets that are separate, I've kind of modeled those triangles into the legs. So it's a bit more stiff, a bit more stable. And for these ones, I decided that I would use M6 screws to kind of screw these corner parts, the corner triangle parts down. Mostly because I didn't check and I thought they were M6 ones on the original design, but it turns out those were M8. But I also had a bunch of M6s lying around, and so use what you got. That's kind of the spirit of this build anyway. Next up, I think the idea is that I'm going to build the entire top gantry assembly and then just kind of set it down on top of it like a hat and then attach it with the M12 bolts. And so I'm going to start with the idler assembly. And so I put the M5 bolt through it, kind of threaded the nut onto it a little bit, and then just kind of pulled it all the way back. And so now the M5 lock nut is kind of seated all the way in the back. And then I'm going to do that for the other one. And then inside of this idler pulley, it's basically just going to be a sandwich of a 1mm spacer, the flange bearing, the normal bearing, another flange bearing, and then one more spacer. And I found that if you assemble this all together before you put it into the top gantry, it's a lot easier once you've got all the pieces kind of shoved in there. So you can see I'm using the M5 bolt as kind of the alignment tool. But once they're all in there, the kind of friction fit kind of stuck in there. And then I can remove the bolt, and then the whole assembly kind of stays locked in there without the bolt. And then I'm going to kind of slide this whole thing into the slot in the frame, and then I'm going to kind of sandwich it with a washer and then a washer and a lock nut on the other side. And then to be able to adjust the tension, I'm just going to use an M5x30 bolt and a washer sticking from the front of the printer. And so when I tighten this bolt, it's going to pull the idler back and just kind of increase the tension. I'm going to quickly pop in these flange bearings that are going to hold the Z-rod nice and straight. Quick and easy, just kind of friction fit inside of there. Next up, I'm going to clean and lube my linear rails. Never trust that factory lubricant on your linear rails to be the lube. And then I'm just going to use some multi-purpose grease up on these little bearing balls in the carriage. And then I'm going to attach my linear rails to this top gantry up here with M3x8 screws, very loosely for now. I'm not going to attach them all the way down. Next up, I'm going to put together the X carriage and the gantry. And here the linear rail is just going to slide through these little openings right here. Two little joiners, and we're just going to use one M3 screw to kind of hold it together. And I use very few heated inserts in this build, but this is one of the spots where I need it because I need this to be a really tight screw because there's only one screw here. And so next up, we're going to put these little idler pulleys in the ends of the XY joiners. And so it's going to be the same kind of 1mm spacer, flange bearing, normal bearing, flange bearing, 1mm spacer sandwich that we did earlier. And we've got two little slots here, one for the top and one for the bottom pulley. After that, it's time to put together the hot end assembly. And so for the hot end assembly, I actually do recommend using heat set inserts. Like I mentioned earlier, biting your screws straight into the bare plastic is good, but only good for like one time, at least for screws this small. And so for all the parts on the hot end assembly, I did use heat set inserts because I knew I would be disassembling it and reassembling it many times over. And so I'm using my LGX light, which has some abnormal locations for mounting, but I had it left over from when I upgraded my 3.1 to a Orbiter 2 extruder. And so I made a little mod to where I could kind of attach it together. And so this one is going to mount onto this little adapter plate that I've got here. It's going to screw in from the bottom, and then I get to screw in the hot end with these little 4 holes right here on the top. And then I should mention that if you don't use your LGX light, you could just use your Orbiter 2 and bite it straight down into these holes. They're in the right spot for the Orbiter 2. And I did a little whoopsie here. Accidentally used M3 by 12 screws instead of M3 by 8 screws. And the screws went a little too far. And so here you can see them kind of busting through the bottom of the housing. Oops. And even worse, they kind of crushed a little bit of the drive gear teeth. And so I did manage to save it. I just scraped off the crushed bits and hoped that there was still enough left for the teeth to kind of work with. And it still worked. So I saved myself $50 there. And so here I am mounting the extruder to this plate with the 4 M3x8 screws. Next up, I'm going to attach my Rapido 2 Ultra High Flow to the hot end assembly. And here I'm just going to use 4 screws and mount it in from the top. Next up, I'm going to attach my extruder with the mounting plate and 38mm of PTFE tubing. And then I'm going to use my M3x6 screws and just kind of attach it down like I would with an orbiter. This one's very tight because it was not meant to be mounted this way, but I didn't want to change up the holes too much just in case I ended up swapping it over in the future. Next up, I'm just going to pre-place this set screw that's going to hold the Super Pinda in place. They use a set screw. I'm just going to use a normal screw because I didn't want to buy a set screw just for this. And so this is going to be my old Super Pinda from my old 3.1. I upgraded my 3.1 to a Beacon, which was an absolutely amazing upgrade. But then I just had this thing lying around, so it's going to be put back to use. Next up, I'm going to mount my hot end fan, and then I'm just going to sandwich it in with this shroud and some M3 screws, and this is going to basically sandwich it all together. Next, I'm going to mount the hot end to the carriage. For now, you're just going to attach these 2 screws to kind of align it with the carriage, and the other 2 will kind of be sandwiching a bunch of things along the way as it bites into the carriage. And if I could just say that this whole hot end assembly is absolutely genius engineering. I did not design this by myself, I did modify it, but it's just absolutely genius the way this comes together and works so well. Kudos to the Ratrig team for designing this thing for me to enjoy. Next up is this little square. It's got the little grooves on it for the belt teeth to kind of bite into, and it's got 2 little cutouts here, and that's for the last 2 screws to kind of sit inside and have clearance. Next up, I'm going to finish the rest of the gantry. So this is going to be the back idler assembly. And so here I'm going to shove the M5 screws all the way up, and then I'm going to do more sandwiches of the 1mm spacers, flange bearing, normal bearing, flange bearing, and then another spacer. And then in some cases where it's got 2 belts passing over it, I'm going to stack another flange bearing, flange bearing, and spacer on top of that. And then here I'm going to put on the cover for the back idlers, and mine just bites straight into the plastic, and so I'm going to come in from the underside and just kind of screw it into the plastic. I think the original design has some lock nuts up on the top side that it screws into. Next, I'm going to mount up the X and Y motors. These are just going to screw down from the top with some really long M3 screws, and they just kind of sandwich everything tight together. I'm not going to put on the timing pulley just yet. I'm just going to leave it bare shaft on there. Next, I'm going to go ahead and use some M3x12 screws to attach the X gantry to these 2 little carriages here. And Of course, to avoid racking, you're just going to screw down one side and then do the other side. Don't tighten both sides at once. I did not know that until recently, but yeah, don't do that. Attach one side first and then the other side. And now with the kind of back idler top hat on the gantry, you can go ahead and tighten down those linear rails on the sides. There's a little key there that kind of holds the linear rails in the position that they want them to be. I don't know if you're supposed to do this before or after you attach the X gantry, or if it matters, but I don't know. I did it now. Next up, I'm going to route up the belts. And so for me, I cut my belts to be 125 centimeters for each belt. You could do a little bit longer than that, but I wouldn't do any shorter than 125 centimeters per belt. So here I've got one of the little belt pod clamps, and I'm just going to take one of my M3x16 screws, kind of get it through the middle, and then I'm going to go ahead and use this to clamp down just one half of the belts. And I'm making sure that both belts kind of end at the same spot, and so I'm making sure that each teeth goes over every single comb and that they're exactly the same. And so once I run my belts all around the pulleys and through the tracks, I'm going to go ahead and run it back. And through here, this one particular spot, if you already have the Z motors attached, it's a bit tricky, but not actually. See, what I do here is just kind of take it, and then I just kind of push a bunch of slack in between the motors, and then it's going to pillow up in between in that little middle section, and there I can kind of fish it over the motor rod. And then from there, I'm going to go ahead and shove on the timing pulley, and I'm going to take a little finesse to kind of make sure that it's centered before I tighten it down. But that's the way to put on the belt through this little back idler assembly here. And so for attaching the other set of belts to the tool head, you see the right side is clamped down quite tightly, and then the left side, I've also used the M3x16 screw just for the middle, and I've kind of got it like semi-tight, like it's tight enough to hold it in place, but not so tight that I can't slide something in there. And so here I'm just kind of coming in from the top or the bottom, and it's just kind of sliding the belt through the teeth of that first belt pod, if that makes any sense. And so once I've got into position, I'm going to slide it straight up, and then once I've got both belts into place and covering the same amount of teeth on that belt pod, I'm going to go ahead and tighten down that little middle screw. And with those tightened down, I'm going to take two more screws and then tighten down the top half of this little belt clamps, and then I'll hit two more screws, and then we're going to tighten down the bottom half, making sure that the bottom half is even more tight, because that also bites into the carriage for the linear rail. Afterwards, I attached the accelerometer using two M3x8 screws and some nylon washers. I didn't capture myself doing it on video, but there it is. Next, I'm going to use four M3x30 screws to mount the part cooling fan. I didn't use the shroud because that means it wouldn't have bit into the threaded inserts as well as I would have liked, and so I left it off so I can get a little bit more clamping force. And now is the time to complete the sandwich. And so ideally, if you're following along, you would have already put your bed carriage, your linear Z rails, and your Z rods into here. I haven't yet in this build. And here I'm just going to use my M12 bolts and just kind of clamp it down and attach this sandwich all together. And after the four main bolts are attached, I'm going to use my M6 screws and go ahead and kind of reinforce these little braces on the side. Make sure your linear rods went through those little flange bearings up on the top gantry, and we're just going to kind of finish locking down this linear rod with this tiny little clamp here on the inside. After that, the hell known as wiring starts to begin. I'm good with mechanical stuff. I am not good with electrical stuff. I don't know, it just confuses me because I can't see what's happening, and so it doesn't make sense to me. But because I'm using the exact same components as the Ratrig VCore 3.1 minus the the SSR relay for the mains powered bed, I'm just going to follow the wiring diagram for the VCore 3.1. And for the life of me, I could not get this thing to boot up. I bought a controller board from BQ because it was on sale for like $40 directly from them, and they sent me a used board, I'm pretty sure, because it didn't have the rubber duck and the packaging wasn't in the normal order when you get a brand new one, and turns out that board was dead. And so I bought a board directly from Amazon because faster shipping, and I'm pretty sure I got a used board because it was missing a bunch of accessories, and the packaging wasn't all there, and that was dead. And so I bought a third board from Amazon, Big Tree Tech, and then that one was finally working. And so finally it posted, and I breathe a big sigh of relief because everything feels like it's going smoothly. Last time I did the wiring for the 3.1, it took me 3 weeks to get that all done. Here, it just took me 2 days to finish all the wiring. So, I really learned how to do wiring a lot from the 3.1. And while I thought all was good because it posted, all was not good. The printer would crash every single time I tried to use any of the motors, and I could not figure out why. In the end, I did figure it out. It turns out that the wires I bought for the motors were not wired correctly, and so I had to unpin the wires and then repin them in the right configuration. I thought it was the power supply, and so I bought a brand new power supply, plugged it in to replace the old one, forgot to switch it to 110 volts, and the power supply killed itself almost immediately after I unboxed it. But yeah, I guess it was just these little wires here. And then after that, I had to learn how to set up sensorless homing, which I had never done before. But luckily I did figure it out. Make sure you've got these two little pins, jumper pins here, connected. And then when following the instructions, I'd set it to max like they wanted me to. And then it would travel in the opposite direction, slam into the wall, and then I would be like, why didn't it stop when it slammed in the wall? But it turns out it already triggered as soon as I hit the button. And so setting it down to like a lower value ended up making this make a lot more sense, and it ended up working out. And honestly, sensorless homing works out quite amazingly. Now, he's a little bit quirky. Getting the software to work was a bit tricky because the original software was set up for the SK Rat, which used only 2 drivers to run all 3 stepper motors, but now I have 3 of them, and so I had to go into the printer config, set up a third motor manually, and then get Z-tilt started. But once all of that was figured out, this thing ran beautifully. And for some reason, the very first print that I decided to push out of it, I went extremely hard and tried to do a 12-minute benchy. As you may notice, that's not the printer shaking. This printer is shaking the entire table. It's kind of whipping it around so fast. And so I'm going to go ahead and speed this thing up by like 20 times. You don't really need to, sit here and watch the whole like 12 minutes. This video is already long enough as it is. And that, fan noise, a little annoying. Right now it's like running at like 80%. On day-to-day life, I usually run it around 30%, which is like more than adequate enough for printing with PLA. And so, there's not very many VChonks out in the world, so I have no idea if these speeds and performance is like typical with this type of machine, but this is what I've got. If someone else has built one, let me know how fast yours is able to push out a benchy. But anyway, we're gonna pull this thing off here and just kind of, for a 12-minute benchy, that's not bad. It's got a little bit of rippling going through that because I haven't really tuned the input shaper on this thing, but like, the overhangs and the bridges, and that line that's supposed to be there when you start doing the top of the ship floor, not there. No drooping, no sagging. The cooling is definitely overpowered, but pretty cool. Not a bad looking benchy. Anyway, at this point I started rebuilding things because I found out that my input shaper was kind of changing by the hour, unfortunately, and I think it was because the one screw that was holding the X gantry to the XY joiners didn't originally have a heatset insert, and so those were starting to break loose, and so I decided I'm going to reprint the XY joiners. And at that point I was like, this black and gold or this black and yellow isn't working for me. It's not as cool as I thought it was going to be. and so I decided to go with the black and green, just kind of original Ratrig color scheme, and so reprinted pretty much everything in green, at least the small stuff. For the big stuff, like this bed gantry, which was perfectly fine, I just went ahead and spray painted it black, and no one will ever know, except for you all. You better not tell anyone. While I was at it, I ended up making some acrylic panels for the side because I was going to try and enclose this thing so I could print some ABS. I really wanted this thing to be my second little workhorse. Laser cutted the back panel because I needed a hole for some of the cables, and then manually cut some clear acrylic rectangles from the scrap that I had lying around the studio. And so the way the side panels attach is I kind of have a little recess built into the legs, and the acrylic panel is just going to sit in there, and then I'm just using M6x12 screws and some washers to kind of sandwich it into place. And honestly, you know what, that was good enough for me. I also ended up 3D modeling and printing this little hat for my printer. This is going to be the top of the enclosure for when I'm printing ABS. It's also got a little hinge so it can kind of flip up and out of the way when I'm not using it. It just kind of slides into place between the two little idler blocks in the back of the printer, and then it just kind of hinges like that, up and down. And then first thing I sent it off to do was to print replacement parts for my VCore 3.1. I was upgrading it from the EVA toolhead to the Ratrig toolhead, and so here we are printing some ABS for it, and it seems to handle it like a champ. Pretty much all of the parts of this 3D printer are printed in ABS, and so I wasn't really worried about the heat creep kind of warping those parts too much. And after printing for about an hour and a half, this enclosure never really rose above like 115 degrees Fahrenheit or about 46 Celsius. And the print quality, quite nice. I mean, it's, you know, I've got a bit of exaggerated raking light on here to kind of accentuate the layer lines, but like when you're looking at it in person and not looking for layer lines, it's actually like quite good looking. You can barely see the layer lines. And then after printing for a while, I did start to notice an issue, and that is the front left idler pulley was eating the bottom of my belt. And I think that the tension screw is right behind the idler assembly, but the one up and down that kind of holds the idler pulley together, it's on the top half of that, and so it tilts it in a way that kind of pulls the belt down. And then the other reason why I think this is because on the other pulley it pulls it kind of up, but that one's not quite as catastrophic as this one is. The next thing I ended up printing was this little litter scooper, and other than the kind of stringy because of the wet filament, I didn't dry out this filament beforehand, it looks quite nice. And I'm printing this because I have a new studio mate. An Amazon delivery driver picked this guy up off the streets but couldn't take care of him for any longer, and so asked if we wanted him. So this is the new studio mate, Touche, because his little stripy patterns remind me of Touche reticulations. I also printed this 3D printer test at 200 millimeters a second. I forgot to dry the filament beforehand, but it still decided to give me a pretty good result, all things considered. I mean, this fan is clearly overpowered again because you can see how it handles this overhang. And when I did calibrate the flow, it ended up being around like 92% for PLA. And once it's down to there, it's pretty accurate. But there's a few things not so great about this printer. Firstly, the issue with the belts kind of shredding themselves. Maybe that's on me, and over this next time I rebuild it, it'll fix itself. But until then, that's my first gripe. Secondly, the build plate has exactly 180 millimeters of travel between the nozzle to it ramming against the Z couplers at the bottom, which means if you print something that is 150 millimeters tall, then it will move the bed down 15 millimeters more after you're done printing, and then the next time you go to home before the next print, it will travel another 15 millimeters down and then basically slam itself into the bottom. To which I had to change my after print height and my homing height to only move the Z 5 millimeters. I see a few ways to kind of fix this. One, to increase the Z height with the linear rails and all that stuff up by like 20-30 millimeters. In this case, you can see my extra thick top gantry. I actually just increased the thickness of the top gantry by 20 millimeters, and so the nozzle sits 20 millimeters up higher. Temporary solution for now, but in the future, I might try to play around with a different solution for that now. As a third thing, I think it's a bit loud. Maybe I'm just spoiled by my 3.1, but I think it's a little bit louder than my 3.1. And so here's it printing a model. And then here's my 3.1 printing the same model at the same distance from the camera with the same speeds and accelerations. My last gripe is that this bed is way too hard to print in ABS. I mean, I don't know, some people probably have better printers than me, but I would say, at least looking at the Discord and everyone else's experience, this singular part is like the biggest barrier to entry to this entire project. Luckily though, I made a mod for that. You see, I tried out printing in PLA, the base, and then using ABS for some inserts where the Z motors interface with the base. And so far, at least I run my printer in standstill stealth mode. They don't get hot enough to actually do anything to the base, and as we saw earlier, the enclosure doesn't really heat up too much, and usually I'm done printing an ABS part before the enclosure can kind of get too hot. So this seems like it's perfectly viable for me. I've been running this one for a few weeks now, and nothing bad's happened yet. And speaking of printing in ABS, honestly, I've been trying out printing without the enclosure, and this thing handles it really well. You see, these two parts right here I printed in ABS, and you know, they didn't lift from the build plate. Granted, they're small, but I imagine you're not printing big stuff with this printer, you're printing small stuff, and it printed perfectly fine. I printed these little gears here in ABS, and the quality is amazing. Open frame and everything, no real problems with lifting. I haven't printed anything massive yet, but for what I need it for, it works great without an enclosure, and if I need one, I could also just wrap it in a plastic bag. That's what my VCore 3.1 is living with right now, the plastic bag life. And on the topic of print quality, it's amazing. So here is this little wolf that I printed, and this is silk PLA, 200 millimeters a second. It's about as fast as I can get with a 0.6 millimeter line, which I always print. I just run into the maximum extrusion that the extruder can deliver. At that point, it's just like over 22 millimeters of like flow rate, and you know, some filaments can't keep up, and so I just try to keep it under 200 millimeters a second. But the pink one printed on the VChonk, undried filament. The silver one printed on my VCore 3.1, also at 200 millimeters a second. But keep in mind, the VCore 3.1 is made with 3030 aluminum extrusions, heavy duty, and the VChonk really gets amazing print quality at super high speeds. And so really, there's nothing I can complain about that print quality. But when we get away from the silk PLA torture test wolf kind of scenario, we're looking at some pretty good quality. So here's some here's a gearbox that I printed for one of my presses on this printer, and you know, yeah, you can kind of see the layer lines, but really it just kind of looks like a texture or a grain to the part. I mean, it looks quite clean. People love it, and you know, I've had this press around, and people love like come up to it, hear me talk about it being 3D printed, and people come up and they say, "This is 3D printed?" No, it's, and then I have to say like, yes, it is 3D printed, and they always ask me what my 3D printer is because they're almost flabbergasted by the quality. Granted, those people are probably working on like their school's ancient like Kiro printers, but I mean, like, quality is great, and my customers think they're beautiful. So another point for good quality in the prints. I mean, who would have thought if you put top tier electronics and components into a printer, even with a 3D printed frame, that you're going to get really good results. And then the last thing I'd like to comment on is the software. Granted, this is still in a beta. You're going to have to play around with it. But I mean, compared to me starting this up from scratch without their software, oh my goodness, the Ratrig software is amazing, phenomenal. It makes setting up a 3D printer dead simple, and their start macro, absolutely amazing. Z-tilt with variable mesh bed probing before each print. It adds a little bit of time, but like the print starts reliably every single time. Like this printer, I can send a print to it without even look at the printer, as long as I know that the build plate's open, and just trust that it will end the print without any flaws. And I don't even have to check on it at all at any point in the process until it's done, and I know it's going to be done. And honestly, that's the highest praise you can give a 3D printer, is just sending a print to it without looking at it and knowing that it will be done by the time you come and check on it next. So is this thing worth it? Assuming you spend about 1 kilogram of filament for the base, 1 kilogram for all 4 legs, and then about a little over 1 kilogram for the rest of the parts, $20 a roll, maybe $60 a filament. This thing, if you buy some dirt cheap parts on AliExpress, can end up being around $626. And if you're considering how much did I pay for this thing, where I spent $300 on Ratrig's kit, $100 of shipping, the power supply that I accidentally killed, and then all of the plastic and ABS from prototyping parts, because not everything worked the first time around, I ended up spending closer to about $758. I know Elegoo's got their Centauri Carbon coming out for only around like $300, $400-ish. That's a steal and a bigger volume. This thing doesn't quite seem worth it at face value, but when I was upgrading my VCore 3.1, I had a lot of leftover parts. So really, I didn't pay for this extruder, I didn't pay for the bed probe, and when I upgraded its height, I could have reused the linear rods and rails for this printer, and that would have saved me a lot of money. But no, it'd still be very expensive. But what this can do for me, and me specifically, is that this has an identical set of electronics for my 3.1. And so when my 3.1 breaks or something goes wrong with it, I can immediately take parts from this thing, transplant it over into my 3.1, and have that thing up and running with minimal downtime. I'm gonna keep spare parts for the 3.1 no matter what, and so I might as well put it to work while it's just waiting to be used. And so really, if I'm considering that I already had all of the electronics on hand, no matter what, then I was really only spending about $250 for all of the mechanical hardware and all of the plastic for this printed stuff. And in that case, it's not so bad. Like I mentioned earlier, software-wise, this thing's amazing. Quality-wise, top-notch. Speed, top-notch. But, you know, you can get a good result out of a $200, $300 printer. You know, it'll still be great. Is that extra speed and convenience worth it for you? I don't know. You might be willing to save about $300 on your printer for a bigger build volume, but a little bit more, you know, fuss and mess, you know, troubleshooting your printer. But for me, this is a nice addition to my setup. I'm putting it to work. You can see it's at work. It's been working nonstop while I've been editing this video. And so I'm not too mad about it. If you've made one yourself, please let me know how your process has been going and how your printer's been running. The belt shredding itself issue, I just kind of let it run and it seems to have figured itself out. Yeah, part of the belt's still shredded, but it just seems to be the way it operates, and it operates fine. So I just leave it be. And then if you want the parts to do this yourself, I did make a fork of the GitHub. I haven't used GitHub in like 7 years, since back when I was in school. So like, forgive me if like I didn't do it right, or if like I don't know, this is formatted weirdly.
I haven't touched GitHub in a long time. Me personally, I think I need a 220 by 220 by like 250 build volume just to make the presses that I actually sell for my business. Right now this prints supporting parts, but it can't print every part of the press. So I'm probably gonna keep working on this thing and upgrade it to a bigger build volume. Should I? I don't know. It might just be cheaper at this point to buy another printer. Personally, I only started 3D printing maybe 2 years ago. And so I'm very new to this. My first 3D printer was an Anycubic Cobra Neo, and then an Anycubic Cobra 2, and then I jumped straight to the Ratrig from there. And so I hear a lot of the OG 3D printer crowd say that, you know, building the 3D printer and the tinkering process is a part of the fun. And honestly, like, I really felt that with building this thing. You know, it's different than buying something off the shelf. Yes, it had its quirks, but I learned so much in the process, and now I'm like feel very confident with 3D printers. The extra $300 that is over a cheaper 3D printer kind of got folded into a learning experience. So I guess I kind of got like $300 worth of extra education versus if I just bought the Centauri Carbon or like any Kubrick S1 right out of the box, perfectly working right out of the box. You know, I don't know. It was fun. I'm gonna tell myself it was worth it. Otherwise, I'm gonna hate myself. Anyway, that's all I've got for this video. I don't usually make 3D printer content, even though I use some 3D printing in my content, so you don't have to subscribe if you're not into art stuff. My next video, we're gonna be back to regular, normal, ancient printing processes. So until then, keep on printing.